An instrument used for measuring the pressure of the atmosphere is called a barometer. In a simple mercury barometer, a glass tube, longer than 76 centimeters, closed at one end, is filled with mercury and tipped upside down in a dish of mercury. The mercury in the tube runs out of the submerged open bottom until the level falls to about 76 centimeters. The empty space trapped above, except for some mercury vapor, is a vacuum. The vertical height of the mercury column remains constant even when the tube is tilted. In a simple mercury barometer, variations above and below the average column height of 76 centimeters are caused by variations in atmospheric pressure. The barometer balances when the weight of liquid in the tube exerts the same pressure as the atmosphere outside. A 76 centimeter column of mercury weighs the same as the air that would fill a super tall 30-kilometer tube of the same width. If the atmospheric pressure increases, then it will push the mercury column higher than 76 centimeters. Water could be used to make a barometer, but the glass tube would have to be much longer, 13.6 times as long to be exact. A volume of water 13.6 times that of mercury is needed to provide the same weight as the mercury in the tube. A water barometer would have to be at least 10.3 meters high. The operation of a barometer is similar to the process of drinking through a straw. By sucking, you reduce the air pressure in the straw that is placed in a drink. Atmospheric pressure on the liquid surface pushes liquid up into the reduced pressure region. The liquid is pushed up the straw by the pressure of the atmosphere. You cannot drink soda through a straw unless the atmosphere exerts a pressure on the surrounding liquid. Boyle's law states that the product of pressure and volume for a given mass of gas is a constant as long as the temperature does not change. The air pressure inside the inflated tires of an automobile is considerably more than the atmospheric pressure outside. The density of air inside the tire is also more than that of the air outside. Inside the tire, the molecules of gas behave like tiny table tennis balls, moving helter-skelter and banging against the inner walls. Their impacts on the inner surface of the tire produce a force that, averaged over a unit of area, provides the pressure of the enclosed air. Suppose there are twice as many molecules in the same volume. The air density is then doubled. If the molecules move at the same average speed, the number of collisions will double. This means the pressure is doubled. So pressure is proportional to density. The density of the air can also be doubled by compressing the air to half its volume. We increase the density of air in a balloon when we squeeze it. We increase air density in the cylinder of a tire pump when we push the piston downward. When the volume of gas is decreased, the density and therefore pressure is increased. The product of pressure and volume is the same for any given quantity of a gas. Boyle's law describes the relationship between the pressure and volume of a gas. P1 times V1 equals P2 times V2. P1 and V1 represent the original pressure and volume. P2 and V2 represent the second or final pressure and volume. Scuba divers must be aware of Boyle's law when ascending. As the diver returns to the surface, pressure decreases, and thus the volume of air in the diver's lungs increases. A diver must not hold his or her breath while ascending. The expansion of the diver's lungs can be very dangerous or even fatal.